that you can see it. Can you please write in chat if you can see the presentation? Yeah, thank you so much. Thank you so much. So, again, as I mentioned before, today's topic is going to be Introduction to Computational Thinking. Today we are going to cover the next 4 aspects, yeah, so which is, again, introduction, understanding the difference between algorithm and program. We'll discuss a concept of abstraction and decomposition, and we'll talk about some problem-solving strategies. And as I mentioned before, we're going to start with computational thinking. So let's try to define computational thinking. Yeah, so the computational thinking is basically what? It is problem-solving process that involves understanding problem and expressing it in such a way that both us humans and computers can understand each other, yeah, or interconnect, interchange information with each other. Yeah? And let's now have a look at key stages of computational thinking. So it can be split into 4 stages here. Again, decomposition, pattern recognition, abstraction, and algorithm design. We are going to discuss each of them in the next slide. And the first thing that we need to understand about computational thinking, why it's even important. Yeah. Why do we need to work with this definition, first of all, of this computational thinking? Again, we need to understand fundamental skills in the digital age. Yeah. Basically, everyone needs to know what computer wants when you want to write prompt on ChatGPT or any other LLM or GPT. Like how you can set up algorithm on your YouTube, Snapchat, Instagram, Twitter, whatever. Yeah. Then another step, it allows us to figure out how to work with more complex problems efficiently. And it can be applied beyond computer science. Yes, I just mentioned in the example before. When you work with your social medias and you are trying to get useful information for you, yeah? Because again, the content that you watch, the content you look at, that you like, that you comment, etc., it depends on the content that you're going to get in future. And again, one examples could be, as I just mentioned, analyzing data trends, yeah, and optimizing business processes, optimizing learning plans, scheduling plans, etc. Now let's have a look at components of computational thinking, and the first one would be decomposition. Yeah, definition of decomposition is basically like breaking down a complex problem into smaller, more manageable parts. Again, for example, when we are solving some computer like programming problem, instead of just trying to write code straight away, we are trying to split it, decompose this problem into simpler problems, so we would be able to understand different approaches. Yeah, so as you can see, there is some example of a puzzle here. So basically, we can just split it into puzzle in such a way that we can connect all of the details together later. Next thing is pattern recognition. Yeah, so again, this is about identifying similarities between each problems or parts of the problem, etc. So what is it useful? Yes, for example, you're working on some solving quadratic equation. Yes, you are learning some pattern, how you would approach some specific problem. Yeah, the same way it works in computational thinking. We are spotting some pattern, we are following this pattern. Or for example, when we are writing some code and we can bump into some error. Yeah, for example, you are writing some Python script and you use different quotational marks, single quotational mark and double quotational mark. Yeah, so after spotting this pattern a few times, he will know that, okay, I made this mistake. I'm going to memorize this pattern. Next thing, abstraction was one of the most difficult or complicated patterns for most of students and people in general. But when we come closer to the definition, we understand that we are just explaining something complicated in a simple way. Yeah, just focusing on important information and ignoring irrelevant detail. Yeah, let's have a look with reference into math. What can we talk about? Yeah, let's talk about right angle triangle. When we are applying Pythagoras, we are not taking into consideration thickness of the sides. Yeah, we just know that it can be ignored. Yeah, so this is an example of abstraction. For example, in math. Yeah, we will go first to examples of abstraction in computer science a bit later. The last for today, yeah, is algorithm design. Yeah, it's basically creating step-by-step solutions to solve a problem. Yeah, there are efficient algorithms, there are non-efficient algorithms, there are sometimes algorithms when you need to give up on efficiency to make it cleaner, etc. We are going to talk about this a bit later in process sessions. Yeah, so now let's have a look at some real-world applications. Yeah, so again, where it can be used healthcare. Yeah, so for example, diagnose diseases through pattern recognition. Nowadays, there are a lot of startups in Silicon Valley that is working on predicting some cancer, yeah, cancer disease, or even working on some treatments and pills for cancer. Yeah, so we know that all of the pills, how they're working, they are connecting as some different proteins, and then they are being applied to some parts in our body. And in case if there is some pattern developed, algorithm developed that can spot these patterns, then we can apply the treatment. Yeah, logistics, again, Amazon delivery. Yeah, so when the driver is going through hundreds of the houses, we need to develop algorithm that would be the most efficient and less time consuming for the driver. Education, yeah, personalized learning plans, example like the one I showed you in the beginning of this series. Now let's talk about algorithms and programs. Yeah, so first of all, let's try to figure out what algorithm is. Yeah, so we know that it is a set of instructions to complete a specific task. This is quite simple definition, nothing so complicated here. Yeah, everyone needs to know it because you will most likely be asked this definition during the exam time. Yeah, and now let's have a look at some common examples. Yes, so recipe for cooking dish. Yeah, for example, I want to cook carbonara. I need to write everything step by step what I'm doing. This is algorithm of action. Yeah, so I have bought a table. I have instruction for assembling this furniture. Yeah, long division in math. Again, you know it. You need to step by step decrease the units. Yeah, sorting list of numbers in computing. We know your algorithm how we are swapping the values, etc., etc. Here is an example of algorithm that can be implemented as a flowchart. We're going to talk about this just a tiny bit. Yeah, so here we can see this example algorithm. We start in case something is true, we are doing something. In case if something not true, we are doing nothing. Then we finish the algorithm. And now let's try to figure out about the definition of a program. Many would say that this is just a software. Yeah, as we know, there are different kinds of software, like system software, user software, etc. Yeah, cloud software. But first of all, we need to understand that the program is a coded algorithm that a computer can execute. Yes, so anything you write, like some specific script file with extensions .c, .cpp, .java, .c#, .py, .bash, .even git. Yeah, so these are some algorithms that computer can execute. Yeah, another thing, we don't know if it's going to be properly compiled there because of the errors, bugs, etc. But again, computer can execute. Yeah, so and we use some different programming languages, as I mentioned before, like proper C, C#, Java. What else we know? Visual Basic, Python, Delphi, Pascal, Ruby, R, etc., etc., etc. There are many other of them that we can use.
Okay, I found this on the web for I said Python and Delphi, Pascal, Ruby, R.
Sorry, it was Siri. Yeah, and again, programs, with human logic, we are writing some specific script. We can turn human logic into machine instruction. Yeah, so in case if we are speaking about low-level languages such as assembly, or different assembly languages that can turn the human logic into what? Into ones and zeros, and then we can convert it directly to the machine. Yeah, so here we can see example of what? Of simple Python script that has a list of numbers, and we applied some script, say number.sort, and we know that in Python, it means that we are going to sort some list. Yeah, and then we are asking the program to print the sorted list, and in the end, we are going to have what? 2, 5, 5, 6, and yeah, so this is an example of a simple program using Python programming language. Yeah, now let's try to compare algorithmic programs and to see the difference between them. Yes, so first of all, we need to understand that algorithm is what? Is our skeleton, the idea, the plan, something that we are going to follow. And program, it is the implementation of that idea in the code, script, etc. Yes, so again, algorithm is a skeleton idea that we follow, and program its implementation or execution. And let's I prepared some table to compare all of them. So they can be compared based on next 6 main aspects. Actually, there could be even more than 6 aspects, but we can compare them by nature, language, focus, flexibility, execution, and optimization. Let's have a look at each of them. Yes, so nature. As we mentioned in the definition, algorithm is concept and program is practical implement. By language, again, algorithms can be defined in whatever way you want to. It can be flowchart, it can be pseudocode, it can be just written list of instructions. Program, they're using some specific instructions, such as programming languages, yeah, that you are using to write some script. The most important and interesting part here that I would like to ask you to pay attention to is focus. So we need to understand that algorithm is focused on what to solve and program on how to solve. Yeah, so algorithm, I have, let's say, I have this suitcase for headphones. Yeah, so and algorithm would be what I want to solve. I want to solve that this suitcase will charge some headphones that are standing and program the code written inside. Yeah, probably they use Java or some assembly language. How to solve the process that this suitcase is going to charge these 2 sets of headphones. Next thing about flexibility, as I mentioned before, algorithm can use whatever, and program just have some specific language the computer would understand. Yeah, because unfortunately we cannot write down any text written by human being. Computer won't program, and computer won't be able to understand. Yeah, you can say that nowadays there are a lot of LLMs, large learning machines, or GPT, different transformers that can try to transform our language into code, but again, it's not a common case. Yeah, now about execution. Algorithm cannot be executed itself, but program can be executed by computer. And again, what is optimization for? It focuses on logic and strategy, and programs focusing on efficiency and resource management. Now let's try to figure out why they would matter. Yeah, as in the beginning of this session, I said that efficiency matters. Yeah, so we can write a code with different efficiency. We can write a code that would be run 1,000 years. We can write a code that would be run in 1,000 seconds. Yeah, I don't know if I have ever mentioned it before, but in case if we are trying to calculate numbers, to print out numbers using Python from 1 to billion, it will take 3 minutes. When we are trying to do it use CPP, C++, it will take less than a second. Yes, so again, we need to use efficient algorithms for our program. Yes, so we need to know if we want efficient algorithm or we need to have efficient program. Again, it helps us to optimize different solutions. Yeah, so again, the better algorithm you pick, the less likely you need to use a lot of resources later in the future. Yeah, so you might ask me a question. So what algorithms are used for such big platforms such as YouTube and Instagram? Because there are millions of videos being uploaded to these platforms on daily. Yeah, so how these companies are storing these videos? So there is some little trick. Just imagine if we needed to just send query for thousands videos, for billion videos, every time we are looking for something. Now imagine there are a million users online sending billion queries at the same moment. So 10 to power of 6 million users, 10 to power of 9 number of queries. It's 10 to power of 15 queries. Yes, so petabyte, whatever it's called, amounts of queries. So this is very simple, beautiful solution, efficient algorithm. They are just caching some most popular videos on the platform, and then there's searching among cached videos. Yeah, for example, out of billion videos, they have billion most popular videos. So now we are reducing the amount of time that we would need to spend on looking for the video that we like by thousands. Yeah. Yeah, and this where we coming for that is critical for tackling complex problems, yeah, such as the one shown below. Yeah, and also you can ask me like why the servers are not being vacated. Amazon, for example, came up with one very interesting solution that they are storing their servers down underwater. Adrian joined. Okay. So they are storing their servers underwater, so they are cooled down automatically and they don't need to spend extra resources on cooling these servers down. Yeah, so again, we would need to what? When we come to algorithm, we would need to identify a problem, then we implement algorithm, then we execute program, and then we have a solution. Sounds simple. So basically, this is how we decompose and abstract all of the problems that we have in the computer science. Yes, so now let's have a look at example of sorting numbers. I'll provide you two solutions. First one, algorithm, another one is program. So first one, let's use flowchart as example of algorithm. Yeah, so we can see what we are doing in the beginning. We are starting and checking if the list is sorted. If the list is not sorted, we are swapping adjusting elements. Yeah, so what is the name of this approach of sorting numbers? Yeah, so in computer science, we usually call it bubbles. Yeah, when we are taking two numbers into a bubble and swapping them. Yeah, so and then we are repeating the action until we reached what? At the end of the list. If we did not reach the end of the list, we keep swapping the element. If we reached, we are checking if the list is sorted. Yeah, so after the list is sorted, we obviously end our. So now let's have a look how it would be implemented. Yeah, we are not going to talk about efficiency of this algorithm, about beauty of this algorithm. We can see that the algorithm that we have defined left in flowchart, we can easily implement in program in some way, in some language understandable for computer. Now the next second half that we are going to start with is going to be abstraction and decomposition. Yeah. So let's start with definition of abstraction. Yeah, we have covered it before, but let's quickly repeat it. Yeah. So it's process of simplifying complex systems by focusing on essential characteristics. Yeah, as I mentioned before, we don't care about the thickness of sides in right angle triangle. When we are applying Pythagoras, we are just taking into consideration most important things such as length of each of these. Again, few popular examples. First one, maps. Yeah, so again, when you are checking the route to go from one place to another one, you don't check if it's like 2-3 meters left, right. Yeah, you are taking into consideration approximate location of first and approximate location of the right. Another thing with user interface. Yeah, so as you know, like we are using HTML code to show different web pages. Yeah, we don't care about the code itself, how it's looking like, how the buttons are developed. Yes, so we just need to put button in position A, in position B, in position C, text in position D. So it would work all together. Yes, so for example, when I'm running this Zoom session, I don't care how the stop share button was developed, etc. I just know that it is there and I can click on it. That's called abstraction. Now, let's talk about benefits of abstraction that it can bring us. So again, as we mentioned before, manages complexity. We are focusing on high-level concepts, and it's easier to communicate and understand our needs. Yes, so again, let's go through each of them by one. And we manage complexity by breaking down some complex problems into few more simpler problems, focusing on high-level concepts. Yeah, we don't go deep into the problem. We are just looking at the some problem that are important for us to solve. Yes, so for example, again, when we are talking about physics, we could instead of just looking for a volume of a box, we could take into consideration the sharpness, how affected the box is. Yeah, we don't usually focus on this. Yeah, we focus just on high-level concepts. Then communication. Yes, so again, it allows developers talk to each other in a faster way in terms of not needing to discuss some deep things that that we are not going to pay attention to in the beginning of the development cycle. Yes, so let's have a look how we can abstract something. Yes, so let's say there is some event A, yeah, let's say we are clicking on the button A. It's some triggers some event, yes, of application logic that we are having execution instruction that is going to programming language that is processing these instructions. Then programming language is interacting with some operational system, whatever it is, Windows, Linux, Mac OS, etc., and sends signal to to hardware. And then we are working with hardware. Yes, so CPU, whatever, or RAM processes your command. Yeah, so we can see there is a huge chain of what's happening when we are just clicking on the button. And this is called abstraction, when we are hiding all of this logic. Next thing is decomposition. So what would be the decomposition? Yeah, breaking down complex problem into smaller manageable parts. Yeah, again, it can be used in many different things in everyday life of regular human being, students, teachers, developers, anyone in this role. Yeah, so project management. Yeah, so again, let's say my project is to provide this course for you. Yeah, so I divided these projects into tasks, into 25 tasks, such as 25 topics. Each of these topics are decomposed into 3-4 subtopics that I'm going to discuss during each section. Yeah, software development. Yes, instead of trying to develop everything together, design, algorithm, database, we are decomposing, we are developing separate features into different modules. Yes, so one person is responsible for design, and another person for algorithm, third person for database, the fourth person is collecting all of this and wrapping up together. research paper, again, like you always and pretty often have many different presentations. Yes, so you are doing like some research if this topic is necessary, if these things is necessary to mention or not. Yeah, quite a few made a lot of presentations about AI, its application in lab. You've done your research. Yeah, so you decided, okay, I'm going to use this site, this platform. I'm going to have a look at these resources at this platform, etc. Yeah, cooking, as I mentioned before. Example, instead of just throwing like cooking carbonara. Yeah, so we know that what do we need to cook carbonara? We need pasta, usually it's spaghetti. We need lardons, for example, some sauce, some cheese. Yes, so in one way we can throw everything together in a pan, and maybe it will be cooked in some certain way, but probably not, right? So we are decomposing it. Yeah, I will boil pasta separately. I will fry meat separately. I prepare sauce separately. Then after all of these processes, after all of this is cooked, I'm going to mix. Yeah, instead writing the same basically as research paper, sorry, and debugging. Yes, so this is most applicable example for us. Yes, so we are checking errors that can come up during writing within the process of writing code. Yes, so we examine writing print statements to check where we can get potential error. Yeah. So, and obviously, what are the benefits of decomposition? So again, simplified problem solving, enables parallel work and easier testing and maintenance. Yeah. So again, let's quickly go through each of them once again. Simplifies problem solving, breaking down difficult problems into few smaller chunks that we can easily access. Parallel work, as I mentioned, example with teamwork. Each team is working on its own responsibility. And easier testing, again, it's easier to test smaller portions of code rather than trying to test the entire program, how it works. Yep. And let's see example of complex breakdown. Yep. So we can split our complex problem into many issues into sub issues, and each issue into details. Yeah, same as I provided example with handling the course content for our session. Now let's see how we can combine abstraction and decomposition. I have prepared two examples. So the first example would be building it. And now we can see we are combining abstraction and decomposition in the next way. So first of all, we are decomposing the car into next elements of the car, engine, transmission, braking system. Yeah, we know that each of them can be decomposed even more. Yeah, engine can have combustion, power generation, transmission, talking about gear shifting, power distribution, braking system, friction generation, and dissipation. And then we can keep decomposing more and more and more. Again, it should be done in a smart way because you can over decompose the problems. Yeah, and when we are talking about abstraction, yeah, so when we are building a car, we know that there should be acceleration developed in some certain way in steering, and again, braking force and deceleration. Yes, these are basic from physics, for example, how you know how we can easily apply basic Newton's law or how to calculate acceleration or deceleration for it. Yeah. So we are not taking into consideration like many difficult aspects about the thickness of wheels, about the quality of roads, etc. We are just applying some basic abstract physics. Another example that is going to be a bit more interesting for you and more applicable in this current case is going to be building a computer. Yes, so we know that computers usually have two components. Yes, so I'm going to mention these two components. I hope all of you already figured out what I'm talking about. This is going to be what? This is going to be hardware and but how can we again, split our computer. So we know we need CPU, we need memory, we need storage. Yeah, we know that CPU, again, there is ALU, some logic happening there. Control unit is working differently, how they are interchanging information with each other. Memory, there is RAM, cache memory. Yeah, storage can be HD or SSD. Yeah, and then we are going to another aspect: how we are processing the data, how we are storing the data, how we are retrieving it. Yeah, how all of the operations are happening. Yeah, we are not discussing it; we are just hiding them, but we know that they are happening. Yeah, there was recently some very popular video clip. They were showing the Apple Silicon M3 processor, like it was zoomed out. You know that this the unit is about 3 nanometers squared, I believe, maybe a bit smaller. Yeah, so and there are like billions of different components stored there. Yeah. Now, the last thing that we are going to cover today is going to be problem-solving strategies. So let's first of all define what a problem-solving process is. You can define it in your own way, but there are basically like 4 main steps that you can apply to each problem-solving process. We need to understand the problem, we need to plan solution, execute the plan, and evaluate the solution. Yeah, so what can be understanding the problem? Yeah, so we need to know what we are exactly going to work on. Again, so let's bring the example of the course content. Again, yes, so my problem is to develop a content plan for 25 weeks. Yeah, I'm planning a solution. I'm deciding to decompose it into weeks, and content for weeks and sub-content for each week. How I'm going to solve it: I'm going to prepare a presentation, I'm going to prepare Google Notes, I'm going to prepare notes, I'm going to use Discord, Telegram to post the information, notes, etc. Yeah, I'm going to use GitHub to store all of this all together. Yeah, so I'm executing this plan. Yeah, so at the second step, planning solution, I define what I'm going to do, and executing the plan, I'm organizing all of the things together. Then I'm evaluating the solution. I'm checking if the resources I picked were efficient, if the information shown is looking good, etc. Yeah. And again, it can be shown in these kinds of ways. Yeah, so we start with understanding the problem, then we are proceeding to the plan, executing the plan, and evaluating the solution. Now let's see how we could do it using Pseudocode. Again, we are going to pay more attention to how to write Pseudocode next lesson. So what is Pseudocode? Yep. In a different literature, at different levels of studying, you can see different definitions and the way Pseudocode is looking like, but basically it's some kind of plain language. Can we please remove annotating? Yeah, thank you. What I was saying, yeah, we can see different ways of how we can define pseudocode. Can we share yes, Andrea, you can share Discord server to other class. Yeah, it's free for everyone. And not just inside of your school, you can share it to whoever you want to. Okay, so I was saying that Pseudocode is basically plain language, yeah, that we are going to describe some out. Yeah, let's have a look. Of its benefits, yeah, it's easy to understand and it's language independent. Yeah, for example, if you're talking at home in Spanish or Italian, if you're talking Hindi or let's say, I don't know, German, you can describe something to your parents in their native language. Yeah, in school you can use different languages to talk to your classmates, which is English in this current case. Yeah, and as you know, these things, pseudocodes are easy to understand because you don't need to use some specific programming definitions. Use input, use for, use if statement, etc. You can just describe it in simple words. Yeah. For example, in case we want to define algorithm how to find the average, yeah, we are setting up some sum to 0 in the beginning, and we are going through each number in the list, and we are adding number to this sum. Yeah, this one is kind of mathematical and Python specific pseudocode, but it's still simple to understand for a person who is not familiar with programming language. Yeah, and we are saying that we are dividing the sum by total count of numbers. Yeah, we know what it means. Everyone knows what total count of numbers is. Then we are returning the result. Yeah, so now let's have a look at flowcharts. Again, next session, we are going to pay a lot of attention to different flowcharts, how to organize them, how to develop, etc. But let's just have a look at what they are usually looking like and what they are used for. Yeah, so they are usually diagrams that are used to represent some algorithm or process. There are some unspoken rules. Yeah, so usually oval is used for starting and then rectangle for some process or action, and diamond for decision-making point, or if or while if you are talking in terms of programming languages. Yeah. So let's have a look at the example that I defined here below. So we have some start and end. So and we would decide if we need to bring umbrella or just go outside without it. Yeah, so we can see there are how many steps here? 5 different steps. Yeah, we can see start and end. So we know we would have 2 ovals. We have decision checking, which would be what? Would be a diamond. And we have 2 actions to process it. So it would be 2 rectangles. Yeah, so let's try to see what it would be looking like. We are starting here, then we are checking. We have decision to make, yes or no. It's rectangle, and the end is ovalus. Again, next session I'm going to show you resources that I prefer to use for drawing flowchart, how to draw it on your own, how to do it using Python code, how to use Google Colab to turn pseudocode into flowchart, other way around, how to turn code into pseudocode. Now the thing about debugging and testing. Yeah. What debugging is usually used? Yeah, so it helps to ensure that the program works as intended, and it allows us to catch all the errors and to fix their errors. Yeah, so for example, yeah, it helps us to prevent unexpected behavior, and it helps us to increase program reliability. We can use step-by-step execution, yeah, when you are running code line by line, applying some print statements to see the expected output, etc. And then test cases, it's a bit more advanced approach when you are looking for some edge cases, expecting that your code will break or work unexpectedly. Yeah. So these are 2 main strategies that you can apply to debug and test your code. Yeah, so that's pretty much it that I wanted to cover with you today. So again, today we covered what key takeaways about computational thinking, about understanding algorithms and programs, abstraction decomposition, and discussed a few effective problem-solving strategies. Next time, again, as I mentioned before, we are going to write algorithms into the code, create some flowcharts for visualizing algorithms, and translate algorithm into Python code, some simple. Yeah. Yeah. So thank you for your attention. And now I'm free to any questions of yours. You can either raise your hand up on Zoom or can write down a question on